So before I jump into the lecture, two things. One is sort of an announcement. If you're having issues connecting with the Wi-Fi, there was some like weirdness that went on with that. Melinda has like the full scoop on it, and may be able to help you with that. I know for myself, I just had to like retype in the password, and I was okay, but that might not be it for you, so you might have more of an issue. Just check in with Melinda if you have an issue with that. Cool. So I posted something. It's just, to me, an interesting thought about sort of the visual aesthetic side of web development, and that, in my opinion, it's missing texture. And so for anyone that's interested, there is a site called magicpattern.design, and then they have like this CSS backgrounds thing that you can use to generate CSS code. It's probably hard to see what this is doing. Make it a little bit brighter for you. So you can basically do all these different patterns, and then you can change the spacing. And if you make it small and subtle enough, it kind of registers as a texture. And I have an example of it in CodePen, which is this right here. So I'm not sure how good it's coming up on the slide, but you sort of have like a textured background. I think it's kind of a cool look and something to experiment with. And so with that, I'll stop talking about that. Cool. So on to important stuff, the actual lecture. Use slideshow. Control-C. Right, so working title, I see I did not update that, but you know, it works. So what are we learning today? So we're going to, this might be a bit of an easier lecture because a lot of what we're learning today is stuff we have already learned in a different language. So we've learned about operators in JavaScript, we learned about control structures in JavaScript, we learned about loops and collections, i.e. objects, as well as arrays in JavaScript. And so we're going to get the benefit of basically, you know, taking what we know from already learning the language and learning a new language. So the first section we're going to dive into is operators. So operators are these symbols, right? So we have comparison operators, equals equals, which checks if item A is the same as item B. We have not equals. We have less than. We have greater than. We have less than or equals, and we have greater than or equals. With logical operators, we can combine things. We saw this also in JavaScript. So and is going to say, okay, if this is true, if A is true and B is true, then the whole statement is true. Or would be if either one of them is true, and then not, you can add the not flag on something, and it basically inverts whatever its Boolean is. Right, and so here's just maybe a reference. So, question, and we'll do this by raising hands. True, raise your hand, false, don't. Well, actually, yeah, true, raise your hand, false, don't. Is equals 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 a comparison operator in Java? Cool, so no one raised their hand. That could just be, you just didn't feel like answering the question, but you got it right anyways, because equals equals equals, that showed up in JavaScript. That was like strict equality, you know? 2 equals was loose equality, 3 was strict equality. In Java, we don't have that, we just have the 2. As we can see in this previous slide right here. Right, so here is an example of the not operator. Once again, not super new material. We have like an if statement. This is all written in Java. And this is basically, is valid is a Boolean that is false. But if false inverted, which makes it true, if true, then print this out. So we could expect that this if statement is going to print out this line because it has the not operator on there, changing false to true. And yeah, here's another example of essentially the same thing. This is the not operator used outside of an if statement. It's just printing the Boolean and it's inverting the value. So we can see right here. Here's an example of the AND operator. So if is valid is true and 1 is greater than 0 is true, then we're going to, well, it's not an if statement, but we're going to print out is valid is true and 1 is greater than 0. And because is valid is false, that means the entire statement is false. So even though 1 is greater than 0, this part is true. Because this part is false, the entire statement is false. Here we have the same scenario. We're going to print is valid or 1 is greater than 0. Even though is valid is false, because one of the two things is true, 1 is greater than 0, it's going to print true. So that expression evaluates to the Boolean true. This expression evaluates the Boolean false. Cool, so we kind of blazed through that. Any questions on this before we move on to if statements? No? Cool. All right, so if statements. Once again, this is going to feel familiar since we've already learned JavaScript. So we have if, it's going to check a single condition, if else, two alternatives, else if, multiple conditions, and then switch statements, which we haven't really talked about, but they definitely exist in JavaScript. We have switch statements that are going to be great for selecting from many different options. So here is some Java code. This is checking if the length of the string cat is greater than or equal to 3. Now here we can expect this is going to print out the string here because it is in fact greater than or equal to 3 in length. And you'll notice here that the if statement syntax, it looks identical. It is in fact identical to the if statement syntax in JavaScript. The only difference is in the print statement right here. This is different. Instead of saying console.log, we have the systemout.println. And then instead of saying like const str equals cat, we instead declare the type string str equals cat. And those are the only two differences between this if statement and the if statements we already learned about and have used inside of JavaScript. So that's pretty great. Here we have if else. So here we're taking the user's input. So we're prompting them with a message, enter your age. We capture, well, this is actually the line of code that has the option for them to input a number. So the user inputs a number. It gets saved in the age variable. And then if age is greater than 99, we're going to print you're too old for Lego. Else, we're going to say you're not too old for Lego yet. If you know, you know. So once again, we're going to see this is extraordinarily similar to JavaScript syntax. The only thing that's different here is is of course how we're getting the user input. This whole paradigm right here, the console log messages, but the if else and the comparisons, they all look the same. And then with multiple conditions, once again, same syntax. So here's a switch statement, and I believe the switch statement is also the same syntax. So with this, we didn't really look at this much in JavaScript, but this is really great if you have like a single value that you're trying to check it against multiple different conditions. And so we're taking a string, which is the day, converting it to lowercase so we don't have to deal with uppercase versus lowercase, all that mess. Then we're saying if it's Monday, we print a message. If it's Friday, we print a message. If it's Sunday, we print a message. And if it's none of those things, we're going to print a default message down here, right? So we're going to open up IntelliJ, at least I am, and we're just going to look at the code and maybe mess with it a bit. Any questions at this point? Yes?
Is there a significant performance difference between a chain of if-else statements versus a switch statement?
Great question. So the question was, is there a significant performance difference in a chain of if-else statements versus like a switch statement? So the answer to that, I'm talking not with a really strong knowledge in this area, but I believe that a switch statement is technically more performant. However, it's probably not. There's probably not a big enough difference for that to be the deciding factor whether or not we use a switch statement over an if statement. Generally speaking, unless we're hypothetically with Java, we could design like an embedded system that could run on a piece of medical equipment or in a car or something. In that case, we might need to really zone in on performance. But for web development and other things like that, typically we prioritize like the readability of the code first. And then if there's any major performance things, of course, we're going to tackle those. But because it's not a significant performance difference, I would say use a switch statement when it makes most sense, like logically reading the code over performance in most cases. But yeah, great question. Cool. Other questions or follow-up questions to that? No? All right, let's move on. Cool. So let me open up my IntelliJ. Let's see here. This is my first time opening up here in class. Does anyone know offhand how to make the font larger?
Did you try Control+?
I did, yeah. Oh, I miss it? All right. Oh, I see it. Okay, it's Alt-Shift+. That's something. Okay, Alt-Shift+. No, it's not working. All right. Alt-Shift period? Oh, yeah. I was seeing the plus because it's combining the commands. Thank you. All right, great teamwork. Cool. So this is just the example we were looking at earlier. Do I have something selected? I'm not sure I'm doing that. So I'm going to run this class. You can see the output. So for this if statement, with the age of 40, we work through the chain of ifs. So if age is greater than 99, 40 is not greater than 99, so we move down to the if else. If age is less than 7, 40 is not less than 7, so we'll finally move down to the else section. And that's where we get the message, you are the right age for Lego. Cool. And then down here, we have a switch statement, which is the one in the example. It's all uppercase Friday, and then once it reaches the case Friday, note that it's been made lowercase. Lowercase Friday equals lowercase Friday, and so then we're going to print this message. I feel like we're moving kind of fast, and maybe that's okay. I do want to know, so any thoughts on things you want to try with this code as far as like conditions, if statements, something you want to write or whatnot? Are there any questions? No? Okay. So we will jump back into lecture. Cool. So loops. You may or may not recognize this image. It was a classic game for PC and a few other platforms. Sweet. So loops in Java. This is where we're going to get slightly different. We have a few new things here. So like JavaScript, we have for loops, which are ideal for a known number of iterations. We have a for each loop. We've done something like for each loops in JavaScript. It's for iterating over a collection of items. while loops. We've seen while loops in JavaScript, so that's essentially like an if statement that the loop's going to keep running until the if statement returns true or false. That's right. Until the if statement returns false, the loop will keep running. It's basically what a while loop is. But then we have this new thing called a do while loop. There may be a do while loop in JavaScript, but we definitely haven't seen it, and I haven't used one personally. So it might not exist. It might. Who knows? Cool. So a for loop, you'll note that this looks remarkably similar. So here we have everything here is the same, except instead of saying something like let I equal 0, we say int, because it's an integer. Integer I equals 0. The rest of the syntax is the same. We have our conditional right here. We have our iterator right here. And then we have something analogous to a console.log. For each loop, this looks very different. The syntax looks very different than arrays in JavaScript, but let's just pretend it's a JavaScript array. Here we're saying for letter, instead of saying of letters, we have this colon right here. So for letter of letters, for letter colon letters, and then we're going to do something with each letter. And so what this for loop would do would just print out A, and then it would run, then it would print out B, and then it would run, and C, and so forth. Right, so definitely different syntax, but you can definitely see the parallel between the two languages. While we have this slide up, any questions on this type of a loop or other things? Yes? Yes, they are. Good catch. Yeah, my slide is messed up. I'm not going to fix it now, but excellent. Thank you. All right, so here we have a while loop. This is basically the exact same syntax in terms of like the while loop syntax as what we would see inside of JavaScript. So up here, we just have our starting variable, and then we have while, we have the condition, and then we have our code block marked by the curly brackets. Then everything inside this code block is going to run infinitely until this conditional returns false. So while I is less than 5, run this code. Each time it loops, we're smart. We have something that's going to increase I, so it doesn't run forever, and then it'll stop once I. Maybe I got the logic back here. We'll have to run this and test this real quick because I'm getting the while condition direction here backwards. We'll test that out in IntelliJ in just a moment here, so I can get myself unconfused. A do while loop. This is probably our first time seeing it, except outside the workbook, right? So essentially, it's just like a while loop. The only difference is the code block always runs once. So even if the loop never runs, it's going to run the code block once, and then it may continue to loop, but it always runs the do section at least once. So you can almost think of it of like where you're putting the code block. Are you putting the code block after the loop conditional or before it? In JavaScript, we do have things like break and continue. We didn't really use them much, but we have the exact same tool inside of Java. So we can use a break statement, and that's going to exit the loop early. It can exit other things. Continue statement, which is going to skip to the next iteration. So you might have like an if statement with a continue in it. Like if this, just skip to the next iteration of the loop, something like that. You don't see those very often, but they exist, and they're useful tools if you need them. Cool, so here's syntax for a break. So what this is going to do is this is going to loop, but if once it reaches the number 5, it's going to skip the print because it breaks right here. And so it's going to print basically numbers, well, the slide's not right, but it's going to basically print numbers like 1 through 9. I believe it's either 1 through 9 or 1 through 10. But it's not going to print 5 because it breaks. Does this make sense? Any questions on this particular slide? Yes?
Just double check here. I thought, is it because break is nestled in the if statement? That's why it doesn't cancel before?
Correct, yes. You're right. Yeah, so it doesn't cancel the entire for loop. It just cancels that. Oh, hold on, does it? Oh, yeah, it cancels the entire for loop. I got confused with continue in my explanation. Sorry, y'all. Right, so this does print out 1 through 4 because it breaks at number 5. Right, sorry. Hopefully that makes sense. Any clarifying questions since I just explained it the wrong way? Nope. So this is the example in which it would print everything except 5, because at 5 we have the continue phrase, it skips the iteration, and then it continues each iteration afterwards. So break, it breaks out of the for loop, everything stops. Continue, it just skips one iteration. Right. It depends on the whatever. If you had a nested for loop, it would break the inner for loop. I assume so. We can test that. Yeah, remind me once we get to the code if I forget to test that theory. Cool, so we have a question. What loop fits this scenario? You get user's input and then validate it, asking them again for input if it doesn't meet the criteria. So in the terminal, you prompt someone, please enter your name, hypothetically, and then if they enter like a 0, you're like, okay, that's not a valid name. We ask them again, please enter your name, and so forth. That type of a scenario. So I'll just have someone raise their hand, whoever wants to answer this. Yes. A while loop could be a good solution for this. I think it's the second best solution. So for a while loop, what we need to do is we need to have a block of code that asks the user for their name, and then validates it. And then inside the while loop, we need that again. So can someone provide another example? Yes. A do while. Right. So, yes. So, I mean, honestly, a while loop and a do while, they could honestly be both just as valid. The way a while loop would be, in my opinion, just about as valid would be if you put the validating and requesting the input inside its own little method, and you were just calling that instead of copy and pasting code. But a do while, it really makes sense for this scenario because you can ask them for the input. You can validate that input. And then if it doesn't meet the validation, it's going to start up that loop. And it's going to keep asking them until we get it right. Collections. So I would say, especially at the amount of information we've been exposed to in terms of Java and JavaScript, probably an area where it's quite a bit different than JavaScript. Java is quite a bit different than JavaScript is in how data is handled, how it's stored, etc. So in Java, we have something called a hash map. So this is like key value pairs. We called essentially key value pair type data storage in JavaScript, we call them objects, which you may have come to realize that objects is not the best word because so many different things can be called an object. And so I would say in Java, we have probably a better word for it. We're giving it its own name. We're calling it a hash map instead of just calling it generically an object. Cool. So we also have array lists, and then we have arrays. And so we're going to break those down a bit here. Right, so a hash map. So for a hash map, we are going to define what data type is the key, and then what data type is the value. I would imagine that the key would either be a string or an integer, probably a string in most cases. And so in this case, we have a hash map, something very much like an object in JavaScript, which contains keys, the person's name, and values, what their score was. And so we create a new empty hash map, and then we can use the .put method to add names and scores to it. Hash maps have a lot of methods, just like what we saw in JavaScript with objects. So we have .put, we have .get. So if we say .get the name of the key, that will give us the value associated with that key. In JavaScript, we could just use like square brackets or just use like dot notation to get those values. Here we need to use a method to get the values. It's a bit different. Also, we have a .remove, so we can remove a key value pair. We have .contains key, so this is going to give us a Boolean. It's going to say, does Alice exist in this hash map, true or false? And then also we can get scores.size, so it's going to tell us how many key value pairs are inside our hash map. Right, so we also have array lists. Now, array lists are the closest thing to normal arrays. I say normal arrays, like normal JavaScript arrays that we're going to find in Java, in my opinion. And so for an array list, they can vary in length. You could start off with one item in them, add 10 more, 100 more. It doesn't matter. You can vary you can vary an array list in its size. Typically, you're only going to have one data type in an array list. However, there is a way to store multiple data types in an array list. I'm having trouble saying that. And I'll show you an example of that a bit later, of how to store multiple data types in an array list. Cool. So in this example, we are restricted to strings because that's the defined type. We create a new empty array list, and then we add item by item. And so we can also use the .get, and instead of putting the name of the key, we're going to put in the index, and that will give us the value from the array. So here's some methods to reference. So we have .add. This is just going to add an element to the array list. We have remove. We're going to have to use the index of the element to remove something. We have set. So we could say at index 0 or at index 5, whatever index we're targeting, we can change the element to be something else. And then, of course, just like with objects, we have .size, and that's going to give us the total number of items in the array list. You might want to do something like .length. I don't think that would work because we have .size. So I'm going to make the assumption that .size is our only option, but yeah, if you're trying .length and it doesn't work, it's probably because you need to use .size. Right, and so now we have arrays. Arrays are, in my opinion, boring compared to array lists because they're not boring, but they're just more restricted. So with an array, I would imagine that developers are not going to use them very often because they are fixed in the size that they can be. And they're also fixed in the number of data types that you can have. And so, with this example here, we created a new array of integers. And we say it has 3 different elements in it. And then here we set 3 different elements in this array. If we were to say something like numbers index 3 equals 4, it's going to crash and not like us because it's a fixed length. So however many elements that we put here is however many that we're restricted to. Here's another way of creating an array list. So we have, we use curly brackets, and we just put the values right in the array. Now, in this example, we're just adding the values directly in there. So, thinking big picture, what might be, this is really an open-ended question, what might be a good use of an array where you might not want or need a full-out array list? Any thoughts on that particularly? And I'll give this a moment. Okay, yes. Okay, there's a valid example. So the example was if you had like fixed data, like the days of a week, so like Monday, Tuesday, Wednesday, Thursday, Friday. You put that inside of a fixed array. And that makes sense because we wouldn't want to accidentally add or remove items from a days of the week sort of collection. So yeah, that's a great example. Any other thoughts on what might be a good use for that? What was that? Top 10 list? Possibly, yeah. You could do like a top 10 list as like an array. You could see that. Yeah, because it'd be fixed in length. Cool. So yeah, I would probably use something like a minimalistic array if I knew that I never wanted to change the size of it. Yeah. Cool. So now let's go ahead and mess around with the code a bit. I definitely want to try the example of using the break statement inside of a nested for loop. Let's jump over here. So we have some code already written here inside our class. We have this whole public static void main method right here, just so I can run the class by itself. I don't have any other structure going on. And so I want to point out these two array lists that we're making here inside this class. So this first one is like what we saw in the slide deck. So we have an array list and we define it as a list of integers. We say, call it numbers, and then we assign it a new empty array list. Here we go numbers.add 1, 2, 3, so forth. If we wanted to do multiple data types, not that there's many valid use cases to do multiple data types, but if you needed to, if there's a good enough reason to do it, you could do something like array list is type object. And then from there, you can add things like strings, integers, doubles, booleans, etc. Now, this does introduce something that's going to come up when we're using Java. And this may have come up a bit in the workbook. I'm not so sure. But we know that an integer, a double, and a boolean, these are all primitive data types. The string is not a primitive data type. It is like an object data type. And so, how is it that we are storing primitive data types and calling them object data types? I'll answer this question in a moment, but I'd actually like to give any of y'all an opportunity to answer this question if you have an answer. Why might that be? Yes? It's wrapping it as an object. Okay, yes, that's the answer right there. To give a fuller explanation, well, I don't know if this is a fuller explanation, but you'll hear people talk about like big B Boolean and little b Boolean. And so if you see like a data type has an uppercase B in Boolean, it's a Boolean primitive wrapped as an object. And so it's no longer a primitive Boolean data type, it's like an object Boolean data type. And that is true for all of the primitive data types. And so uppercase I with an integer is an integer as an object. Because d with double is going to be a double as an object. And so here we have an uppercase I integer. We could also do this as int, but it's going to complain because it's expecting object. I do int. No, array list doesn't like that. I think it wants object types. Let me see if I can do that with an array. So we have int equals, hold on, oh yeah, I need the name of it. We need the semicolon. Cool, so for a generic array, I can use primitive integer. I don't think it's gonna like this. Maybe it does. Yeah, it doesn't mind. So it's gonna give me either option. I could do lowercase boolean and do true, false, true. I can change it to uppercase boolean. And it doesn't complain, but it's doing something different. So now these are like object booleans as objects. And so when we see this array list here, the reason why we're able to have all these different primitive data types in here that are not the same type, it is because they're wrapped as like they're object types. And so once again, you can think of the difference as like if it's uppercase or if it's lowercase, that's going to be the hint as to which one it is. Cool. Right. So follow-up questions to this or other things that we've covered so far. Yes.
For a regular array, if you, let's say you initialize it as like a size of 3, but only add 2 values to it, will you get an error if you try to use it, or will it still work on 2 values?
Let me see here. My brain's real rough on the syntax. I'm gonna have to pull up my slides here. Let's see here. Okay. New. That's right, isn't it? Yeah, that looks right. Okay, so we could say a small array 0 equals true. One equals false, and then 2. Right, so we have 3 items in there. It's not complaining. And so your question was, well, what if we leave an item off? What if we don't declare this item? Is it going to complain? Let's run the code and find out. See if it complains. So it looks like it doesn't complain if we haven't set the second item in there yet. However, I'm sure it should complain if we said something like this. Trying to add a third item to it. At least the way I understand it, this should, yeah, this crashes and burns. So if we try to add a fourth item to the array, it's going to complain. But I don't think it's going to. It's not going to crash if we haven't set all the items yet. So it has a fixed length. I'm actually curious if we don't set this. If we print out the index 2, let's see what we get. And don't need these right now. Let's run this again, see what happens. Okay, so until we set the value, it looks like it's going to be null, right? So it has all of its values, just one of them's null. Cool. Yes?
Would you say that's
I don't know. I'm assuming it's null by default in Java. In JavaScript, it is see as undefined by default, right? And if we wanted to say, hey, this is intentionally undefined, we would call it null. So yeah, I think what you're saying is valid. That would be a difference at what would be the default, null versus undefined. Cool. Yes.
What is happening with the string object that always gets passed into the main method? Or are we going to learn more about that later?
I'll be honest with you. My knowledge has not caught up to that. I've got a rough idea that this is probably some stuff that's happening behind the scenes. So we basically have an array of arguments, and so when we're running the main function, when Java's running it, it's probably passing some values in here behind the scenes. But I'm not sure. Yeah, this may come up later. It's definitely something I could learn on as well. Cool. Thanks for the question. Yes.
So would you just use like a dot add to add that to the array there? If you left that second index out, and then you could just use a dot add to add?
I don't know if .add is going to work with an array as opposed to an array list, because we have .add over here with our array list. Let's try .add. Yeah, I don't think it likes this because it wants us to specify the index that we're adding something to. And we can't really do that with a .add. And so I believe, based off of that, .add is just an array list thing, not an array thing.
So how would you add that?
That would be this example right here. So it would just be, you would use square brackets to identify the index that you're assigning the value to, and then say it equals whatever. And so you could move this somewhere else in the code. We can move this all the way down here. Doesn't really matter. But yeah, that'd be the approach. Cool. Thanks for the question. Did you have a follow-up question to that, or no? Cool. Other questions while we're here? Yes.
Is scope the same in Java as it is in JavaScript? Even the square brackets kind of base kind of yes, but that's how it works.
Right. So the question was, is scope the same in Java as it is in JavaScript? I am sure that there are nuance type differences, especially because in different like variable types in JavaScript, like const and let and var, which is technically valid. So I'm sure there's some nuancy type differences, but what does behave the same are these code blocks, right? And so, yeah, because everything inside of Java is written inside of a class, we will handle a lot of the scoping with things like this dot something, and that's going to refer to the current class, or we might refer to a value using super dot something referring to a parent class, or if we leave off this, then we're probably within the block scope. So I would say because Java is all it's all stuck in this whole class structure, the scope might feel different than how we interacted with it in JavaScript, because we didn't use classes a lot with JavaScript. We were just working out with functions and other things. And so it might feel a bit different, but it's in terms of how classes work, it's basically the same. So for example, and we'll talk about classes next week, but for example, you might have a method, and let's say the property is aardvark inside the method. So that's the parameter, the function parameter, method parameter is aardvark. But the class also has an aardvark value, and the parent class also has an aardvark value. When you send a value to that method, how does it know which aardvark value it is? Because it's the parameter in the method, it's the property in the class, and it's the property in the class's parent. the way you would know is using like the this and super type thing. So if you reference aardvark without saying this or super, it's just going to be that method parameter. If you say this.aardvark, it's not going to be the method parameter. Instead, it's going to be the current class's parameter. And if you say super.aardvark, it's not going to be the method parameter, and it's not going to be the class parameter. It's going to be the class's parent's parameter. And so that's mainly how we'll be working with scope. But yeah, it is block scoped as well. Yes. Cool. Great question. Definitely have time to talk about that more next class, Monday. Other questions, follow-up questions? Yes.
Beside the hash maps, what's the easiest way to locate values?
But with a hash map, I'm sorry, what?
Is there a way to locate values directly?
To add values directly?
Or update them? If there's values, then updating it.
Right. So I believe there's the there's like a method.
So you can do it with that book, but if there a different one, just say that.
Right. That's a good question. I don't know off the top of my head. My assumption is that given the way Java is structured, it's going to be with a method. Because with classes, generally they'll protect values as being private values, and then the way we interact with them is through methods, through things like getters and setters, and through other methods. So my assumption is going to be that this is the way to do it, but without Googling it and kind of digging a bit deeper, I don't know. Yeah, thank you for the question, though. It's a good question, because with JavaScript, we could just say, scores dot Alice, and then say equals, and make it a new score or something like that. Cool. Yeah, so actually we're pretty close to studio time. I actually crept up. Let's see here. Let me see if I can do a quick for loop. I'm gonna risk frying my computer with that number. Okay, and then here we'll say, I know there's a shortcut way to write the system out command, but we're just gonna say system out J. Then we're gonna say break, and then there's a few characters you can type in, and then tab. Thank you. Appreciate the assist there. All right, so let's run this nested for loop here. What we're testing is how this break command is going to affect the outer for loop. If the break command does not affect the outer for loop, it's going to print 0 through 9 or 0 through 10, depending on how this less than thing works. My brain always has to try to find out. And then inside of here, we're hoping that it does not run the inner for loop this times this, right? So to get rid of the other noise, we're going to comment that out, run the code, cross our fingers, and find out. So it prints right, so every time the outer loop runs, it prints, this might be an easier way to do it. Outer, did I misspell that? My brain, oh, it's the double quote thing that always gets me. So what this is doing is every time the outer loop runs, it runs the inner loop, but the inner loop only runs one time because we have a break statement, and that breaks out of the loop. And so then this just happens like 10 times or something like that. Let me confirm the number because that was bugging me. We end at 9, so it runs 9 times. Sweet. So that is it for lecture. I'll meet you all back here for studio review at 8. Yes, my brain's questioning everything. Cool. Good luck, and I'll see you later.